Chapter 4, Graph Theory and Networks. Yeah, you're going to love it. So this whole graph theory business started several hundred years ago by one of our friends, Euler, who we're going to learn about in 4.2. And we'll talk about why it even happened to begin with. But it has ramifications even today. And in fact, you might be using graph theory anytime you try to run some errands. If you try to think about, okay, I need to visit these 3 places, what order should I go in so I don't drive as much? Like, for instance, the 2 stores are next to each other and one store is far apart. It doesn't make sense to go from one of the stores that is next to another store, drive out to the far one, and then come back to the other store that's next to the previous store. You might want to say, okay, I'll start from the furthest and then work my way back in. Whatever, that's all graph theory. Now, the stuff we're going to do is on the small scale. We'll only be visiting 3 or 4 other places. And what really happens, like if UPS or FedEx has a truck or whatever, that truck has to visit dozens of places every day, and think about how many trucks they have. They're going to be using computers. We don't have that luxury, so we're doing everything by hand, so that's why we're doing everything on the small scale. In the first section, section 4.1, we introduce a bunch of terms. I forgot to mention this chapter has a lot of terms. You're going to love it. And I mean, like, there's about 20 to 30 of them. So highly recommend some note cards. So again, going back to 4.1, introduction of all these terms, a lot of drawings. And this basically builds up for the entire section. In 4.2, we learn about these 4 terms: paths, circuits, Euler paths, Euler circuits. First off, that's pronounced Euler, not Euler. If you say it wrong 3 times, he visits you while you sleep. So don't do that. And then you'll learn what an Euler path and Euler circuit are and why they were historically important. And then 4.3 is really the big section in terms of practicality. Practicality? Yeah, I'm going to use that word. This is what UPS and FedEx use. Hamilton paths, Hamilton circuits, and the traveling salesman problem. So that is the problem that has no known solution. And that's where, if you are a traveling salesperson, how would you visit the houses that you need to visit in order to minimize the distance you have to travel? So that's the stuff where UPS and FedEx use computers and whatnot to solve their problems. And then in section 4.4, trees. Hooray! You're going to love that too. You'll learn what a tree is, and you'll learn the various types of trees. And the one that we really care about is what's called a minimal spanning tree. So how would you branch out to various points, but using the least amount of distance, so to speak, depends on the problem. So that's chapter 4 in a nutshell. Graph theory and networks.